Okay, the topic here today we are going to discuss on the DC machines. I will just tell you what do you mean by DC machine in general. Okay, what do you mean by DC machine? And this DC machine, when I'm going to consider it as a DC generator, and when I'm going to consider it as a DC motor. Okay, there are two conditions. There are two parameters where the machine it can be converted as a generator or a motor. So the construction details for a generator and a motor it seems to be same. Okay, the construction details it's very quite similar, and even the principle on what principle we are going to work. Okay, that is nothing but a principle is nothing but it is Faraday's law of electromagnetic induction. Yeah, both the generator and the motor it works on this principle, and whenever we speak about this before starting with the principle you should understand what you mean by DC machine and what is the next it is DC generator. When you're going to say it is DC generator and when it is said to be a DC motor. Okay, coming to the first thing. See, as we all know that if we take any electrical machine, this generally deals with energy transfer. The machine, either I can consider it as a generator or a motor. In general, the electrical machines generally deals with a transfer of energy. That energy, either it can be the energy which you are transferring, that it can be a electrical energy or it may be a mechanical energy. Okay, so either it may be a electrical energy or it may be a mechanical energy. So what we are going to do is we are using this electrical machine to transfer the energy from electrical to mechanical or from mechanical to electrical. Like suppose if you take the best example, you are using your 1 HP motors for pumping the water from underground tanks to overhead tanks, right? So what is the process there we are using? We are using a motor where that particular motor it is driven with electrical energy. Means I should give a supply for that motor with respect to electrical energy. What is the ultimate task it is going to do? Once after taking the electrical energy to the motor and that particular pump, it will pump the water to your overhead tanks. It means it is doing some mechanical process there. It is pumping the water from lower potential to the higher potential or from bottom to top. Right. See, I'm transferring energy. I'm giving electrical energy and I'm converting it to a mechanical task. Okay, this is nothing but a electrical machine. Electric machine either it can transfer energy in the form of electrical to mechanical or it may be from mechanical to electrical. So hence the word we can say that the complete machines are nothing but here it is electromechanical 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 energy conversion. Okay, this is the chance that it is going to taking place. So electromechanical. Electro is nothing but electrical and mechanical. Either it can convert electrical to mechanical or mechanical to electrical, but the energy conversion it is taking place. Energy conversion is taking place, hence it is said to be a machine here. Now, suppose if I am particular about whether I am transferring electrical to mechanical or mechanical to electrical, you should be very particular, right? You can't generalize. I can't use the same machine for doing for both the tasks. You have to differentiate. Suppose if I want to transfer energy from electrical to mechanical, which machine I should use? If I'm transferring from mechanical to electrical, what is the kind of machine I should use? So if we go for the classification, the first one is nothing but your DC generators. Okay. Or I can say in terms of using DC word, I will just use a basic thing. It is your electric generator. Okay. I can go for electric generator. What is the job of this? I will tell you. Okay. The second one is nothing but your electric motor. This is your electric motor. See, you have two types of machines here based on the energy conversion. Either I can go from electrical to mechanical or mechanical to electrical, vice versa. Okay. So I should use a specific machine for undergoing that particular task there. So I have two types of conversion, that is electric generator I can use or electric motor. So now if you want to be more specific about that, the first thing, whatever I have told you, that is your electric generator. Okay, they may ask you even in a Viva and all, what is the difference between a generator and a motor? Simple, a generator, okay, whenever it converts, so the energy conversion, if it is taking place from mechanical energy into electrical energy, you always keep in mind in an electrical generator always the energy, that is a mechanical energy, that is mechanical energy will be transferred to electrical energy, electrical energy. Okay, this is called as your DC, what is it, electric generator. Okay, coming to the second one, that is nothing but electric motor. The second one is nothing but your electric motor. Here in the electric motor, electrical energy will be converted to mechanical energy. Mechanical energy. Okay, these are the two basic classification that you can see under your DC machines. Okay, any electric machines, these are the two things. Now, in your syllabus, you are going to discuss on the DC generators and DC motors. So, see, DC, the word you know, that is a direct current. I'm not speaking about a AC parameters. Okay, so you are going to study about the DC generator and as well as a DC motor. So these are the two topics we are going to study, and from today we are going to discuss about the what is DC generator, what is the principle, what is the constructional details of the DC generator, what is the EMF equation, all the parameters with respect to generator we are going to study. Now you know that generator is nothing but where the energy, any energy, okay, the machine which converts a mechanical input into an electrical power is nothing but your DC machine. To be more specific, see, I have told you about electric generator here, I didn't use the word DC. So if you want to define what is DC generator, what is DC generator, so the definition of DC generator, it states that the machines which convert mechanical input power to mechanical input power to DC electrical power, DC electrical power. So I should give some mechanical input in the form of power, and that mechanical input power, it will be converted into a DC electric output power. DC electric output power. See, DC, it states that it is a direct current. So if I am giving AC input also, it will convert it to DC just by using some of the components in your construction details. I will tell you that. Okay, so this is about your DC generator. If I want to define what do you mean by DC motor, see, this is the next topic we are going to study in the further classes, right? So the DC motor, here the machine which converts DC electrical power, DC electrical power DC electrical power into a mechanical power. It will convert DC electrical power into a mechanical power. So these are the two differences you should very clearly know about the generator and the motor. See, for example, in the motor, I have told you just one example. I will give power, either it may be a 230 volts or whatever it is, the 230 or 415, I'll be giving to a motor. I will be giving to a motor, and this motor, it will be used for for converting, this is my electrical energy, and here the task will be done, that is the water will be filled in the overhead tank. Water and the overhead tanks means it is doing some mechanical energy here. Similarly, if you go for a generator, what is a generator? You will be using your generators in your buildings also, right? So for moving the lift, the lift or the excavator which you are using in your buildings, that is not completely sufficient with the electrical energy. What we will do, either I will take a diesel. Okay, I will just take a diesel or thing, and that will be given to a prime mover, where this prime mover, it will be moving in a mechanical energy, where this mechanical energy in turn it will be connected to electrical energy, and this electrical energy, it is utilized for, it is utilized for it is utilized for moving. Okay, this electrical energy, it is used for moving the staircases or the particular lift from first floor to second floor to third floor. And even suppose the battery backup, I'm not speaking about UPS. Okay, I'm just speaking like you should supply. Just if you go for your theaters, malls, or if you go for any normal areas where if you go for any party halls and all, if no power, the electrical power, suddenly they will turn on the generator. In this generator, what it will do, the prime movers, the turbines will be rotating, and this mechanical energy will be converted into electrical energy, and this electrical energy, I can use it for any purpose that is required directly. So you know the applications you have used vast, you are presently using in the vast condition, but you should know how exactly it is going to work. What is the principle of that particular DC generator? Now today we are going to discuss on the principles of DC generator. Okay, the principle of DC generator. As I told you, whenever we say about the working principle of DC generator, always the generators, you consider any kind of generator, okay, all kind of generators, it works on the principle of dynamically induced EMF. Okay, dynamically induced EMF. You know the word EMF? Okay. Dynamically induced EMF. I'll tell you what is this dynamically. Okay. And even what is this? How this dynamically induced EMF? This EMF, how it is inducing in the system? That is mainly because of the principle of electromagnetic induction. Electromagnetic induction. This it is very simple, no? Because electromagnetic induction means I will just take a small example. If I want to undergo the electromagnetic induction, I'll take one coil, and this coil it will be given with some energy. Okay, I'll just pass the current. As soon as I pass the current, what happens? The flux lines will be there, and this flux lines, it will be having the magnetic flux lines that will be induced in the system, and the EMF will be induced. EMF will be induced because of this conductor which is having a current, and the magnetic flux lines will be thing. Or you can take two bar magnets. You can take two bar magnets north and south, and I have one coil here. Either I'm going to move this bar magnets, or I'm going to move this coil so that the EMF will be induced. So this principle and all you have studied, right? So the basic principle or the general principle of operation or the working of a DC generator, it works on electromagnetic induction. It works on electromagnetic induction. And this EMF, whatever I have told you, it is inducing a dynamically induced EMF, right? So I can indicate what is that the dynamically induced EMF. I will just indicate it as a small e, and this EMF which is inducing in a system, it is mainly because of the flux changes in the system. So I can write it as the EMF, the induced EMF is directly proportional to d phi by dt. d phi by dt means as the flux changes, if it is varying in the system with respect to time, there will be a induce of EMF in the system. There will be a induced EMF in the system. And this E, it is not any angle, it is just a magnitude value. It's just a magnitude value. Okay, so how exactly this flux is being generated? Just now I have told you the flux is produced with respect to variation of time, right? So whenever as I told you, either you keep the conductor constant or you keep the magnetic poles constant, one will be rotating. Okay, the relative motion can be achieved by rotating the conductor. So what I will do, I will just keep two magnets and I will keep this conductor here. I will either try to move in a clockwise direction or it may be in anti-clockwise direction. When the conductor, when it is moving, when it is rotating in its own axis, the flux lines will be, the flux will be induced in the system because the conductor is a rotating part here. Okay, and this conductor, it will be given with some amount of energy, so it will break or it will what is that intersects with the magnetic flux of forces, and hence the flux, the rotating flux with respect to the conductor will be reduced. Okay, when the flux has been induced in the system, when the flux has been induced in the system, and hence the voltage gets generated in the conductor, the voltage will be induced or it will be generated in the conductor as there is a long exist of the relative motion with respect to flux between the conductor and the coil, conductor and the coil. So whenever we consider, as we know that I have a conductor and I am giving some amount of energy for the conductor, and hence the conductor, it will try to rotate in one particular direction or it will try to move in one particular direction, and hence it is going to cut the magnetic lines of force, and hence the flux will be induced in the system. Hence the flux is induced, and the cause or the induce of the flux is the major thing where it is going to generate an EMF or it may be a voltage in the entire system. Okay, whatever the EMF, the EMF that is induced, okay, just because of the physical movement of the coil, I'm just moving this coil, right? When I'm moving this coil, just because of this physical movement of the coil, okay, with respect to the flux lines, with respect to the flux lines, there will be a induce of EMF. That EMF is nothing but a dynamically induced EMF. Dynamically means dynamic, static means it is a constant. Dynamic means there is some motion. There is some motion in the process. So the conductor, it is moving and it is cutting the magnetic lines, and hence the flux is induced. Just because of the induce of the flux lines, there will be a generation of dynamically induced EMF. Dynamically induced EMF. And you may get a doubt, who is going to move this conductor? See, the magnetic lines also, it is constant. Even the conductor, I am going to keep it in one place. But who is going to move this conductor? So to move, to have the rotation for the conductor, I am going to use one particular external device. Okay, one particular external device, the name called it is a prime mover. I'll be using a prime mover to move a conductor or to rotate a conductor either in the clockwise direction or it may be in the anti-clockwise direction. Okay, and now you know that the prime mover, what is the job of this prime mover? Please remember these words where I'll come back in the construction. Okay, the prime movers are used to rotate the conductors in clockwise or anti-clockwise direction to generate the or to induce the flux linkage in the system, and hence it is responsible for dynamically induced EMF. Getting my point? So the next is we have the armature windings. Armature windings. Okay. See, suppose the voltage is there. I am just using only one conductor, and the voltage, it may be exactly the whatever the voltage or the EMF that is induced in the system, that may be 1 volt. Suppose I want to boost up this voltage. I don't want to use only one conductor. If I want to use more number of conductors, if I want to use a more number of conductors, because I should induce more amount of voltage in the system, hence we are going to use the armature windings. So if you want to have the larger voltage across the output, the number of conductors which you are connecting between the magnetic flux of force, it has to be increased. So I can't keep it in free space or free air, right? The conductors. So it should be wounded or it should be connected from one conductor to other conductor. Either the connections, I'll tell you, we have two types of connections, whether it may be a lap winding or wave winding. I'll come back to that later. Okay, now just stick on to the word. If I use more number of conductors, the more EMF will be induced, and hence the application it can be used for a higher ratings. For that, I should connect a more number of conductors which should be connected together in a specific manner. I can't blindly connect. Okay, I should use some technique and I should connect it in a specific manner to form a winding. That winding is nothing but my armature winding. That I think it is nothing but a armature winding. See, I was telling you about when it is in the transformers, I used to tell it is a primary winding, secondary winding. What do you mean by winding? Winding is nothing but I'm going to take group of conductors and I'm going to connect it in one fashion. That is nothing but a winding. So, but here I'm going to connect it in a fashion, okay, and I'm going to increase the voltage. That particular thing is nothing but your armature winding. And the next thing is the flux. As I told you, the flux is induced in the system, and this flux is a major cause of inducing the EMF, right? See, as the flux line increases, what happens? The EMF will be increased. It means the flux is directly proportional to EMF. As I'm increasing the flux lines, obviously my voltage or the EMF between across the generator also can be increased. Now, if I want to increase the magnetic flux lines, okay, what is the major cause? Whether it is a voltage or current, that you should understand. Means, if I'm increasing the supply voltage or the supply current, and I can't blindly increase the current and I can't increase the voltage also. So I'm going to maintain the constant voltage, whether it is a 230 volts or 415 volts or 3.3 based on my requirement. So I'm going to give this voltage, but the flux lines, whatever the flux lines that it is generating here, no, that has to be increased. So the one thing you have to remember is the necessary magnetic flux lines. The necessary magnetic flux lines, it is mainly produced because of the current. It is because of the current. That means the flux lines, whatever the flux you are producing here, the flux lines, these flux lines are mainly produced because of this current parameter, current carrying windings. Okay, so you are even in the windings, we have the voltage carrying windings and the current carrying windings. So in the generator, the flux will be induced, or the flux production, it is majorly because of the current carrying windings. And that current carrying windings is called as a field winding. The current carrying winding. See, please remember the terminologies. If you want, you write down somewhere. So the current carrying winding is also called as a field windings. So if I want to increase the magnetic flux, which is produced by the current carrying windings, which is also called as a field winding, And one more parameter we have here. Now, as we all know that I have a conductor and I have a magnets here. This is my north pole and this is my south pole. As you all know that from north pole to south pole there will be a magnetic lines, the dotted lines which I am indicating now. Okay, this is nothing but my magnetic lines. And this conductor, what it will do? This conductor either it move in the clockwise direction or it move in the anti-clockwise direction. Hence, suppose if I take my reference, if I take a reference of this conductor as something here, when it is moving in this direction, see it is cutting these lines. This is my lines now, it is cutting these files. Okay, if it is cutting these lines, so there will be an angle. So initially the reference angle for conductor is this one, and next position it will go here, next it will go here, next it will go, it will be rotating, no, the angle it will be made here. The angle that is called as theta, and this theta is nothing but the angle between the plane of rotation and the plane of flux lines. Okay, plane of rotation and the plane of flux line theta, which is measured on basically from calculating the value for EMF. So I can write down the equation as E is equals to VL V sin theta. VLV sin theta, and this is nothing but a voltage, that is in terms of volts. What is this V sin theta? V sin theta is nothing but it is a component of velocity which is perpendicular to the flux lines, and hence it is responsible for induced EMF. So this sin theta, see the angle between here we are going to measure, no? This angle between the sin theta, this is a angle which is going to actually measure what is the amount of EMF that is induced in the system. So you have this equation, the EMF E is equals to BL into V sin theta, where V sin theta is a component of velocity, and this theta, if I vary the theta, so when theta is equals to 0, when it will be 0 according to this diagram, if the plane of rotation means the conductor rotation, if it is parallel to the flux lines, that means my conductor rotation angle is also here, my flux lines is also here, so both are parallel to each other, means they won't intersect at all, they won't bisect like this, right? So my angle is also here, and even the plane of what is the magnetic flux lines is also here, hence the angle theta will be 0. Suppose if theta is equals to 90 degree, it means that the conductor it has moved 90 degree, and my flux lines is somewhere here. Obviously from north pole to south pole the flux will be moving, and the conductor it is rotating and it is exactly opposite, it is 90 degrees. So it is making an angle here, it is exactly 90 degree. So hence the plane of rotation is perpendicular to the plane of flux lines. So this is my flux lines and the plane of rotation is here. So both are perpendicular to each other. Hence the EMF will be maximum. So sin 0 is 0, right? If sin 0 is 0, what is my EMF? If this is 0, the entire thing which is multiplied by 0, so my EMF will be equal to 0. So if theta, the flux lines, the flux line and the what is that current carrying conductor movement, both are the angle is 0, hence the EMF will not be induced at all. If my theta is equals to 90 degree, theta is 90 degree means sin 90 is 1, so you are going to get BL into V, that is a maximum voltage or the maximum EMF will be induced when theta is equals to 90 degree. Okay, so this is the next thing you have to remember. The next one more small thing that I wanted to share you here. See, whenever we speak about this generator, no, just now I have told you, I have one conductor, I have north pole, south pole, the EMF is induced. Okay, so in generally, the basic nature of EMF induced in the DC generator, always it will be pure sinusoidal wave. See, I will tell you, this you have already learned in the third module. Okay, I have two conductors, I have one conductor here, and I have the flux lines, something like this, the flux lines. So initially the flux lines, and I will just take some different color here, and even the conductor shaft is here itself. The conductor shaft is here itself. Now see the flux lines and the conductor shaft, both it is in phase, hence theta is equals to 0. So hence my EMF will be 0. Not to worry about this condition now. Okay, I'll go for the next condition. Now I will try to rotate this in a anti-clockwise direction. When I start rotating this conductor in anti-clockwise direction, this particular indication, whatever it is indicated with the red, this was under the axis. Now it will come exactly opposite here. When it comes here, see, this is my conductor and this is my flux lines. Both are perpendicular, that is theta is equals to 90 degrees. The angle between them I am going to measure. The theta is equals to 90 degree, hence the EMF will be maximum. Maximum, that by with equation I can say it is BL into V. Okay, and when you go on varying this conductor rotation with respect to time or with respect to some voltage, see, if I take even with respect to timer, so when time t is equals to 0, my conductor was in the 0 position. When time t is equals to 10, the conductor it is in some position making an angle theta 45 degree. If it is 45 degree, I am going to get BLV into root 3 by 2. Some angle I am going to get next increasing. So I am going to get complete something like sine wave like this. Complete 360 degree I am going to get like this when the conductor it is moving. See what is this? This is a sinusoidal wave. Right, this is a sinusoidal. If it is a pure sinusoidal, means as the variation of time taking place, the flux lines or the EMF also it is completely sinusoidal in nature. Hence, this is said to be a alternating in nature. Yes or no? It is said to be a alternating in nature. But I am speaking about your DC generator. You know the difference between the alternating and DC, right? Alternating, it works for both positive and half cycle. DC is nothing but always it works for direct current. Now whatever the output I'm getting, it is completely in the form of sinusoidal, and this sinusoidal I can say even in the word it is alternating in nature. Now I should have the DC voltage. I should have the DC voltage, okay, not the alternating EMF. So to have a DC voltage, I should use one particular device in a DC generator wherein it converts alternating, okay, wherein it converts alternating EMF to a unidirectional EMF or a DC also you can say. Okay, unidirectional EMF. If I want to convert this alternating to DC, means this negative thing it should not be present. Alternate DC means only positive it should be there. Okay, so this positive nature, if I want to obtain converting this alternating to DC, I am going to use a one particular thing that is called as commutator. See, you should know this commutator. What is the purpose of using commutator? If I ask you, you should know. In a DC generator, whatever the EMF I'm getting, that is completely in alternating in nature. Hence, if I want to convert alternating EMF to a DC EMF or unidirectional EMF, I'm going to use commutator. How this commutator it works, I will tell you. Getting my point? Okay, so these are some of the terminologies that you should remember in the DC generator. Going on to the next one, now we will switch over to the constructional details of DC machine. Why I'm telling it is in terms of DC machine is the construction details of DC generator and DC motor, both it retains. Almost it will be same. Okay, the constructional details of DC generator and DC motor almost it is same. Hence, instead of giving DC generator, DC motor to be specific, not to be specific, hence I am using a word, it is DC machine. The constructional details of DC machine. I think, is this visible for you? The diagram, construction of a DC machine. See, this is my DC machine. This is my DC machine. See, you can see the, what is that? Different parts here wherein they have given with the numbers. Try to understand with the numbers. See the first number, whatever on the top, the whole one that is given now, that is your I bolt. What is the purpose of using this I bolt? I bolt, it will be used for making the machine to be connected in one particular, to be installed in one particular location. Okay, if I simply keep without any molding, without any connectivity, the vibrations, the harmonics will be induced in the system, hence it will be responsible for reducing the efficiency. Okay, so the second one is nothing but your yoke. I will tell you what is the job of this yoke. Okay, this yoke, it is used, the main function of this yoke is to provide the mechanical support. Okay, this yoke is nothing but this complete circle. You can see this, the complete circle, right? So that complete circle is nothing but your yoke, and this yoke, it is going to give the mechanical support to all the parts. and it also serves like it is the outermost cover of the DC machine. The yoke is the outermost cover of the DC machine so that the insulation materials gets protected from harmful atmospheric element. It's not that I'm going to keep the DC generator completely in the closed room, right? It can be subjected to some atmospheric condition, whether it may be a temperature, pressure, or humidity, moisture content. It can be projected anywhere. So hence this yoke, it is going to have the protection. Hence this yoke, it is going to have the protection. And the next one, you have your pole core and pole field winding. Okay, what do you mean by pole? You should understand. Okay, what do you mean by pole and what is the function of the pole? So here, if we go for pole, there is two terminals. One is a pole core and a pole shoe. See, you can see your pole shoe here in the fifth terminal. I will just explain you in parallel. What do you mean by pole core and pole shoe? Okay. See, where is that fifth one? See, fifth one is here somewhere. See, this is nothing but my pole shoe. Okay. And the third one here, it is nothing but, see, they have given, shown you here with this. This is nothing but my pole core. So this pole core, the pole core, basically it carries the field winding. See, as you know, what do you mean by field winding now? The field winding are nothing but a current carrying conductors, right? So we require current carrying conductors. I should use current carrying conductors somewhere. It has to be mounted. So I am going to use the pole core. I'm going to use this pole core, this particular region, for making a windings with the field winding. That is nothing but a current carrying winding. Okay, I'm going to wound my current carrying windings on this particular, and thus current carrying windings are the major responsible for protection of the flux lines. Okay, and what is the next? It directs the flux produced through the air gap and the armature core and to the next pole. See, initially conductor is here and it will try to rotate in the other direction. When it starts rotating, the flux lines from one pole to the other pole, it will be having a connectivity. For having a connectivity from one pole to other pole, you are using this pole shoe. We are using this pole shoe here. Okay, this pole shoe, it also enlarges the area of the armature core here. See, this armature, it will be moving. This armature winding, it will be moving, and this pole shoe, which is having the wider area, which increases the area of the armature core to come across this flux lines. Okay, and when it is coming across a flux lines, which is necessary to produce the larger induced EMF. Okay, which is going to have the larger EMF production just because of your pole shoe, just because of pole shoe. Okay, and this is about your pole and the pole shoe. And pole field winding is nothing but on the pole, on this particular pole, I'm going to have the field windings. Field windings is nothing but a current carrying windings, current carrying windings. And what is the job, what is the main function of the current carrying windings or a field winding? Okay, so this the current carrying windings, which is on the pole core, on which the field winding is placed, and hence it is going to produce a maximum magnetic flux lines. Okay, which is going to induce a maximum flux lines. These are the main source of having the maximum flux lines. Hence, it is going to place it on the poles. Okay, and even what is the choice of material? Like if you go for any field winding, what kind of material you are going to use? Okay, so whenever we go for any field windings, in general, we are going to use the windings or the conductors. It is of aluminium or copper. Both it will be in choice. The copper, little bit it is costlier compared to the aluminium. Either I can use aluminium and I can use a copper because it has a good conducting capacity, good pliability. It can be bent easily. So all the flexible parameters are present with the aluminium and copper. Hence it can be used. Hence it can be used. Okay, so the next one is nothing but your armature core, and you have your armature core and armature slot. I will come back to that. Okay, the first thing is nothing but your armature core, and even we were speaking about the armature winding also. I have told you what is the job of the armature winding, right? The first thing is your armature core. You should understand. The armature core is nothing but you can see the teeth like a gear-like structure you have now between like a circular fashion. This is nothing but your armature core. See the number 6 indicates it is the armature core, and the armature slots means a teeth-like structure you have on that armature core. That is nothing but your armature slots. That is nothing but your armature slot. This armature core, which is in cylindrical in shape, this cylindrical, or you can say it is said to be a circular in shape, and it consists of many slots on it. Okay, and what is it? Many slots are the peripheries which is present, and even the air ducts. Air ducts means air bubbles will be filled, and this permits the air flow through the armature, which serves the cooling purpose. See, if I'm not giving this, teeth-like structure, now there will be a complete circular path, and hence the air which is entering this to the armature for any cooling purpose, that is not happening with the 100%. Okay, so if you are providing these structures, what happens? The air ducts or the air drops or the air what is it? Content that will be stored, that will be present on these slots, armature slots, and this is responsible for having the cooling process in the generator. Okay, so the main function of the armature core is to provide the house for the armature winding, okay, or the armature current. And the second path is I can reduce the reluctance. Okay, reluctance for the magnetic flux of lines with respect to your field winding. Okay, what is the type of material that it is used here for the armature core or armature slot? You should understand here. Okay, so when we go for what is it? Material. So generally we should concentrate on the more laminated areas, and it should be highly insulated. Okay, a thin steel laminated construction, it is preferably used for this armature core and the armature slot. And coming to this armature winding, armature winding is nothing but your winding that is having the interconnection of the armature conductors. See, as we know that there is a conductor, and that conductor it will be moving in one particular direction. When it is moving in one particular direction, it will be having its own armature winding, and this armature windings it will be rotating in nature, where the field windings it will be what is that? It will be placed in the constant place. Hence, this armature winding and the field winding both it will come in contact with this pole shoe, and hence the flux leakage or the flux induced in the system it is possible. And this flux lines it is in turn it is going to generate the EMF in the system. EMF in the system. And I told you about the commutator just now. What is the job of the commutator? How exactly it is going to be used? What is that? Okay, the commutators, it is basically, it is used for converting an alternating quantity to the DC quantity. Alternating to the DC quantity. Okay, the next is nothing but your brush. See, these brushes are what is that? Brush gas also it will be called. This it is mainly used for. See, I can see the where are my brushes here? I can see the brushes here. So this is my armature winding. So making that armature winding to connect to the prime mover, as I told you, to drive this conductor, if I want to move this conductor in the clockwise or anti-clockwise direction, I should use a prime mover. Prime mover, I can use any turbines or any gear systems. Okay. But if I want to mount, if I want to keep this conductor on that prime mover, I should use these brushes. Okay, brushes are the stationary and the resting part on the surface of the commutator. Okay, what these brushes will do, it will collect the current from the commutator and makes it available at the stationary external circuit. This conductor's internal it is connected to brushes, and this brushes it is going to take the current. What is that current? It is induced in the system. Okay, and we have even the footing. The footing is the base one. Okay, the base one. See, the base it has to be provided in a proper way, because whenever this generator when it starts moving, no, the armature winding it will be moving, and hence the continuous flow of charges it will be taking place, and hence it leads to harmonics, or it may be some vibrations. So these vibrations, harmonics, it has to be reduced, means the base should be proper. The footing of the generator it should be very proper. Okay, next is nothing but a series field winding. Series field winding is nothing but your commutator windings itself. Commutator winding itself here. See all other parts which it is given here, that is 4A, 4B, all those things it is given here. So the basic construction of a DC generator is I'll be having two parts. One is a armature winding and one more is a field winding. Field winding it will be on the poles. Armature winding it will be kept on the armature with the slots, and hence the conductor when it start rotating, the armature winding it will cut the flux lines, and hence there will be induced of a EMF in the system. See the constructional details for DC generator and DC motor, both it is same. So try to understand the concept and try to remember this. This is very important. Okay, so these are the constructional details of your DC machine. Hope you have understood.